Welcome to the Lesson 34 activities for college algebra. We're going to be doing some regression here. We have some data in Table 1 for mobile telephone service. Today, almost all residents have cell service. And here I have my data shows the year and the percentage of Americans with cell service. And I'm going to start by creating a scatter plot of my data. So I'm going to enter the data, look at a scatter plot, and then find a regression model. So here's GeoGebra. I have it small here so that I can look at my data and enter things at the same time. In fact, I think I'm going to do this. There we go. So I've got the spreadsheet view open. If you don't have that, you just go View, Spreadsheet, toggles it off and on. So the problem tells me to use x equals 1 for 1995. That's my first year. So I have 1, and then my data goes from 1995 to 2003. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 years of data. And then in my B column, I'm going to put, oh, wait, so sorry, it goes to 2012. I've got another column here. So that's another 9 years, 18 years. All right, and then in B, I put the Y values. So I have 12.69, 16.35, Okay, so there's all my data. I'm going to highlight all of it. I'll make this big first. Right click, create list of points. And I can see some of it. I just have to adjust my viewing window to be able to see it all. So my years go from 0 to 18, and my percentages go from 12 to 98. So I need to move my Y's so that I can see. I'll probably just start at 0 and then pull this down so that I can see up to 100%. And then my years go all the way to 18. So there's my scatter plot. And again, I don't like looking at these labels. I'm going to hide them. Oh, that looks like a really classic S-shaped curve. It's like tilted upwards here, and then it's tilted downwards here. This is called concave up and then concave down. We've got this S shape. So I think a logistic model is going to be best here. So let's go back to our notes. So find the equation that you believe models the data best. So it says try several models before deciding, but I'm pretty convinced that I want to use a logistic model. So I'm going to do the regression and I'll write it in the space, write the equation in this space here. Okay, so I'm going to jump back to GeoGebra. I'm going to type in fit logistic. And then I just have to tell it what list of points. And my list of points was called L1. Ooh, that is a nice fit. Very good. So here's my formula up here. I'm just going to pull this over so I can see the whole thing. And I think I'll just grab it by taking a picture. There's my model, 105.74 over 1 plus 8.92 e to the negative 0.26x. So graph the equation of our best fit model in the same window as the scatter plot and see that it's a good fit. It definitely was a really good fit. Touches almost every data point. So I don't have to try another model because I like that one. We want to use the model to calculate the percentage of Americans with cell service in 2013. That's 1 year after this, so I'm going to plug in 19 into my formula. So go here, and I want to do f of 19, 99.34. Oops, that's supposed to be up here. F of 19 was 99.34. Okay, so to discuss the value returned for the upper limit C, the carrying capacity, that is the numerator of my model. What does this tell you about the model? So it says 105.74 is my carrying capacity. And remember, this output represented percentage of Americans with cell service, and you can't have 105.74%. So this is a little bit of model breakdown. If the model were exact, our limiting value would be 100%. That the percentage should approach 100 as t approaches infinity. Okay, here's another problem. This time I have a table that shows a recent graduate's credit card balance at the end of each month after graduation. So I'm going to put this all in GeoGebra. So I think I'll make this small, and I'll make this small, and I'm going to delete everything that's in here and delete the data that's in my spreadsheet. Okay, so my months goes from 1 to 8. And the credit card debt is 620. And 2154.92. Okay, so all my data's in. I'm just going to highlight all that data, right click, create list of points. Okay, we want to find the best fit regression model that fits the data best. So they are not telling us what kind of model to use. So I'm going to look at the scatter plot to get an idea of what's going to work here. So my x values go from 1 to 8. So I only need x to go up to 8-ish. But then my y values goes from like 600 to 2,000. So I need to see a lot more y. And actually I might this there. Ooh, that looks exponential. That looks like my jumps between months, the jump in the amount of debt. It starts out relatively small, 600 to almost 800, and then 800 to almost 900, and then 900 to 1,000. So they seem like pretty linear at first, but then they start getting bigger. 1,000 to almost 1,300, and then 1,300 to 1,600. So these jumps get bigger and bigger. So I think that looks like an exponential curve, which is really not good for your debt. So I'm going to do fit EXP for fit exponential. And my list of points is list 1, and that's a really great fit. And this is my model, 522.89 times e to the 0.18x. So that goes here. Okay, so if spending continues at this rate, what will the graduate's credit card debt be 1 year after graduating? So that would be 12 months after graduating. So I go back to GeoGebra, and I'm going to type f of 12. So I'm just putting a 12 into this formula for x, and I get almost $4,500. 4499.38. F of 12, round to the nearest hundredth, so that is 4499.38. Okay, new set of data. 2007, a university study was published investigating the crash risk of alcohol-impaired driving. Data from 2,861 crashes were used to measure the association of a person's blood alcohol level. So we're measuring the association of a person's BAC with their risk of being in an accident. So table 3 shows the results of the study. The relative risk is a measure of how many times more likely a person is to crash. So for example, a person with a BAC of 0.09 is 3.5 times as likely to crash as a person who has not been drinking. So I'm going to enter this data into GeoGebra, look at a scatter plot, and come up with a regression model, just like we've been doing in the previous examples. So I'll make that smaller, delete everything that's in here already. Okay, so BAC of 0, and then we have 0.01, 0.03, 0.05, 0.07, 0.09, 0.11, 0.13. All right, relative risk of crashing. So at 0, the relative risk is 1, because if you haven't been drinking, you compare that to the risk of somebody crashing who hasn't been drinking, the ratio is the same. Okay, so at 0.01, the risk goes up a little bit. It's 1.03 times as high. And 1.06, 1.38, 0.09. Okay, so I'm just going to highlight all this data. Right click, create list of points. And then I'll make this a little bigger. And I'm change the axes so that I can see my data. So X goes from 0 to 0.21. So I don't need to see quite as many X's here. It's good, I think. And then Y goes from 1 to 100. There we go. I'm going to hide my labels. Okay, that definitely looks exponential. You can see small jumps at first and then big jumps in the likelihood of a crash. So I'm definitely going to do fit exp list 1, really good fit. And so here's my model. Okay, so here's the equation of our regression model. After 6 drinks, a person weighing 160 pounds will have a BAC of about 0.16. How many times more likely is a person with this weight to crash if they drive after having a 6-pack of beer? All right, so I go to GeoGebra and I want to plug in 0.16 for x. X is BAC. So I want to put that into my function f. So I do f of 0.16, and I get 26.35 times as likely to be in a crash as someone who was not drinking. 26.35 times. All right, my headset is running out of batteries, so I'm gonna pause here and I will create a new video for the rest of the activities for lesson 34.